Hello everyone, my name is Kevin, the pre-sales engineer of Overseas Department from Yizumi. Now I will give the presentation. Application of chemical forming in the injection molding industry. For this topic, there will be three parts. In the first part, I will give the brief introduction of the forming process. The second part, we will focus on the chemical forming process. And the last one, we will see the application case on show. Okay, for the first one, it's about the forming process profile. It can be three sections as well. I will introduce them one by one in the next. Firstly, the forming process technology. Actually, forming process is the short calling of microcellular forming. It's a kind of special process which combines the thermoplastic material and the supercritical fluid together in the injection molding. Due to the temperature and the pressure change in the mold after injection, the supercritical fluid will be diffused and start to bubble inside the product. Finally, we can get the ideal product structure, as you can see in the picture. We call it sandwich structure. Next, according to the forming principle, there are two types of forming process. One is the physical type, another one is the chemical. For the physical forming, there is the pattern, which is called mold cell process. Here, you can see the configuration of the mold cell system. On the right side is the supercritical fluid generator. Actually, is the gas source treatment devices to pressurize on the nitrogen or carbon dioxide gas to make it into supercritical state. Then the supercritical fluid will be stamped and mixed with the material inside the barrel during charging. After that, the melt material will be injected into the mold cavity through the start of nozzle. Finally, the supercritical fluid will start to bubble inside the product. Additionally, the size of the bubble can reach less than 50 micrometers, which can create an uniform structure in a lower material density. Okay, for the third part, the chemical forming process. Compared to the physical type, the configuration of the chemical forming process is becoming simpler. As you can see in the picture, there is no connection of the gas source treatment device in the machine. We can use the chemical forming agent to replace it. And during the material charging, the chemical forming agent will be mixed with the material inside the barrel. After injection, the forming agent will start to bubble inside the product as well. Additionally, the size of the bubble can be kept in a range of 10 to 100 micrometers. Next, in the second part, we will talk more about the chemical forming process. First, the feeder of the chemical forming. First of all, easy to use. As we introduced above, in the chemical forming process, there is no need to use the gas source treatment device in the machine. As a result, it can be convenient to use, and on the other hand, it can save the space and the cost. Secondly, weight reduction. As the bubbles are diffused inside the material, to some degree, it can reduce the material density so that it can reduce the product weight. And the percentage of the reduction could be 5 to 30%. On the other hand, it can improve the product service quality as well. Next, lower cavity pressure. As we know, the cavity pressure is related to the material viscosity. As the bubbles are diffused inside the material, it can help to reduce the material viscosity and help to increase the flowing ability for easy injection, so that it can reduce the cavity pressure, and finally, it can reduce the clamping force requirement. In another word, for the same part, we can apply the chemical forming process with lower tonnage machine compared to the conventional injection molding process. Additionally, it will reduce the energy consumption and the operating cost. Next, process cycle time. Here, we can see the comparison of the process time between the conventional process and the chemical forming process. The most outstanding point is the holding time. As the bubbles are diffused and forming inside the product after injection, there is no need to holding for the material shrinkage. As a result, the holding can be eliminated. On the other hand, as the material flowing ability has been increased, the injection time can be reduced as well. Additionally, after applying the forming process, the thickness of the product can be reduced, so the cooling time can be reduced further as well. Next, the chemical forming process system. The configuration of chemical forming process is simple. First, the injection molding machine could be the normal machine with some options, such as special screw, start-off nozzle, and the special back pressure control. Secondary, the raw material. For the material, it could be the same time as to the conventional process. And the chemical forming agent will be added into the material. Thirdly, the mold design. The mold design should be increased to meet the requirement, such as the hot runner system and the sequential control system. Here, we will introduce the chemical forming agent. Generally, there are two types. One is the heat generation type, another is the heat absorption type. For the first type, it could be ADC, OPS, and TISH. Normally, they will release the nitrogen gas and a small amount of water. For the heat absorption type, it will release the carbon dioxide gas and a small amount of water as well. Here, we will introduce the chemical forming process solution. Generally, there are two common types. One is mold lock. What does it mean? It means that the mold keeps static and not open after injection. So the space for the chemical forming is limited. As a result, the forming ratio is low and the weight reduction is low as well. The second way, we call it callback control. In this way, the difference is in the fourth step, the forming step. In this step, the mold will open slightly with high precision control after material injection, so that the space for forming is getting bigger. Finally, we can get a better forming result and a weight reduction of 20 to 30%. Additionally, I would like to mention that for core back control, it's more easy to get succeed in two-plating machine. Next, we will talk about the mold design requirements. The mold design is another key factor for the chemical forming process. Firstly, the gate runner should be hot runner with sequential gate valve control. Secondly, the gas exhausting groove should be strong so that it can maintain a uniform lower pressure environment for the bubble forming. Thirdly, the temperature could be lower than the conventional process. The last one is the flow length ratio. Even the material flowing ability has been improved. The flow length ratio design should be acceptable to avoid the negative effect during the injection. That's all for my presentation today. If you are interested, please feel free to contact us to discuss more. Thank you for listening and have a nice day.